Okay, so here we are. It is day 9 of Advent of Code, and you might notice that I've actually gained my second star from yesterday. Still haven't managed to get my second star from day 7. Didn't happen. But yesterday, I kind of just all broke at the end. It just really broke. But I stopped the stream and I had a little look for my code, and I found this while loop here, and I had loads of different conditions going on here. I scaled it right back. I took one condition out of here, I put it down here, and was a bit more thoughtful about how it worked. And it just worked. I had all the logic was there. I was just doing one really silly thing up here in my while loop, and it was causing it all to come crashing down. So suffice it to say, day eight is done. Okay, I've got both my stars for day 8, so we've only dropped 1 star so far, which I feel is pretty good going, and I'm really hoping that today we can get both stars for day 9. Now look at this gap here between 8 and 9. I feel like we're going to get a much bigger picture than we ever have done on a previous Advent of Code before. We are, look at this is 10. 11 is nowhere to be seen. I think this might be a map or something. Anyway, without further ado, let's jump into day 9 and see what puzzle we've got to solve today. So day 9 is an encoding error. So for those of you that might not have been following along, we are the cold contexters that we're going on holiday for Christmas, and we've been trying to get there. We caught a plane, and I think yesterday we were looking through bags on day 7, and then we were fixing some kid's Game Boy that we were sat next to yesterday, and now we've got an encoding error. So with your neighbor happily enjoying their video game, that's the kid I just mentioned, you turn your attention to an open data port on the little screen in the seat in front of you. Though the port is non-standard, you manage to connect it to your computer through the clever use of several paper clips. I'm a bit of a genius by doing that. That's really clever of me. Upon connection, the port outputs a series of numbers. Ooh. Which is our puzzle input, which we'll get in a second. The data appears to be encrypted with the Exchange Masking Addition System, or XMAS, although I'm sure you will. X at Christmas. I thought they were using clever computer science words. They weren't. They made this up. Which, conveniently for you, is an old cipher with an important weakness. Xmas starts by transmitting a preamble of 25 numbers. After that, each number you receive should be the sum of any 2 of the 25 immediately previous numbers. Okay, so after these 25 numbers, each number we receive should be the sum of any 2 of the... Okay, yep, sure, fine. The 2 numbers will have different values, and there might be more than one such pair. This is going to involve a lot of ifs, I think. If. Suppose your preamble consists of the numbers 1 through to 25 in a random order. To be valid, the next number must be the sum of 2 of those numbers. So 26 would be a valid number, as it could be 1 plus 25, or loads of other pairs, such as 2 plus 24, and so on and so forth. 49 would be a valid number, because it is the sum of 24 and 25. 100 would not be, because none of the previous 25 numbers sum to 100. Cool? I get it. Suppose the 26th number is 45. So the the first number we're going to check, and the first number, no longer an option as it is more than 25 numbers ago, was 20. Now for the next number to be valid, there needs to be some pair of numbers among 1 to 19, 21 to 25, or 45 that adds up to it. So 26 would still be a valid next number, as 1 and 25 are still within the previous 25 numbers. 65 would not be valid. Yep. Cool. So here's a larger example which only considers the previous 5 numbers and has a preamble of length 5. So I think this is what we're going to use for our test data. So let's take this and just take a copy of it. Okay, in this example, after the 5-number preamble, so what they mean is we've got 5 numbers here, 1, 2, 3, 4, 5. Okay, so after these 5 numbers, this next number should be the sum of these numbers here. So 35, 20, so we've got 40. Can we add 2 of those numbers to make 40? Yeah, we can. We can add 15 and 25, and that'll give us 40. So this is valid. In this example, after the 5-number preamble, almost every number in the sum of the 2 previous 5 numbers. The only number that does not follow this rule is 127. So where's 127? Here. So this is not a sum of the previous 5 numbers, which are these 5 here. Okay, so none of these will add up to 127. The first step of attacking the weakness in the Xmas data is to find the first number in the list after the preamble, which is not the sum of 2 of the 25 numbers before it. what is the first number that does not have this property? Okay, and we've got this little test data here. Like, oh, look, there's some numbers here. That's lovely. Let's have a little look at our puzzle input. And all of these numbers, that is what we're going to write a program to solve. All of these numbers, look, oh, they get quite big. Oh, lordy lord. Okay, this is going to take a bit of programming. So without further ado, let's jump into REPL.it and start writing ourselves a program. Now, we are in 2020, day 8, so we're on day 9 now. So I'm going to update this to tell it to run my day 9 file. I'm going to add a day 9 file. That'll be helpful. I don't want to add it there, though. Let's try that again. In 2020, let's add our day 9 file. So we're going to call it day9.py. We're also going to add our data file. So let's add another file and call it day9data.txt. And that's where we're going to store all of our data. In day9.py, I'm just going to paste in my test data. And I'm going to do my super secret keyboard shortcut. So if I do Control, Alt, and Up, I can select all of the lines at once. And then I can press Shift 2 and put a speech mark, go to the end of the line, speech mark, and comma. Look at that. What an absolute pro. That was so quick. Oh, I impress myself sometimes. Okay, and we're just going to pop a bracket there. And this is going to be our list of test data. Let's shunt all of this across one. And we are going to say test data is equal to this array, and this can come back here. Okay, lovely. So we've got our test data. Let's also get our actual data. So Control A to select all, Control C to copy it, and we're going to bung this in to this data. There's 1,000 numbers that we've got to look through here. So luckily we can write a program to do it, and we don't have to do it manually. So we've got our test data here. Now what we need to do is we need to write some code that will be given 5 numbers. So for instance, these first 5, and a separate test number, and we need to test whether any of the previous 5, any of those 5 numbers we were given, will add up to make our test number. So let's write a function, and let's say check numbers, or check number is sum. That's probably a more thoughtful name I could put there. And we're going to pass it a list of numbers. Oh, let's try that again. A list of numbers, and we're also going to pass it our test number. Okay, and now we're going to go through our list of numbers, and let's just take a for instance. Have I done something to this array? Why has this changed color? I'm not sure. Okay, I'm sure it'll be fine. Oh, it's because I've left this for loop open. Let's take this here. So our list of numbers is going to look something like this. Let's get rid of these lines. Okay, so our list of numbers is going to look something like this, where we have a list with 5 numbers in it, and we're going to say for number in list of numbers. Although really, I guess what we want to do is we want to do 2 loops. It's going to be a nested loop again. This is like the 3rd day in a row. Let's do for I in range, and we're going to go to the length of our list of numbers. So however long our list of numbers is. In this example, we've got 5 things in it, but it could be any number. And we are going to say for j in range of our length of our list of numbers, which is still going to be 5. And I is going to start now. I'm going to get in flashbacks here to the other day where I goofed up here and it ruined my code. But let's let's stay positive. I think this is right. So I think I need to be going from 0 to the length minus 1. Yep. And then I need to be going from j. I need to be going from 1, because it's important that I don't overlap. I don't do the same number twice, to the length of list of numbers. Okay, fantastic. And what we're going to say is we're going to say sum is equal to list of numbers at position I add our list of numbers at position j. It would probably be helpful if I cast these into integers. So I will just do this int and ints, because I don't want to be using strings. And I want to return true if that is equal to our test number. So I'm going to say if our sum is equal to our test number that we're going to be given, then I would like to return true. Okay, if we get through all of these and we've not returned true, then we're going to return false. And let's try this. So let's say, let's just take this first little bit of test data here, and let's run this function. So what did I call it? Check number is sum. I'm going to give it a list such as that, and I'm going to give it the next number. What's after 47? 40. Now, we've already established that we can add 15 and 25 to get 40. So this function should return true. So if I say result equals check number is sum, and then I print out the result, when I run this, we should get the value of true print out on the right here. Let's have a look. Bosh, wabam, true, fantastic. And if I change this to 41 and run this, false, great, okay, lovely, because none of these numbers here sum to 41, but they do sum to 40. So this is working, this is fantastic, this is lovely, this is great. This is everything I ever dreamed of. It's all so good. So this example has a 5-number preamble, but we have a 25-number preamble. Yeah, okay. After that, each number you receive should be the sum of any two of the 25 immediately previous numbers. Okay, so we're going to need another loop. So let's write a function for part 1, and we are going to expect some data. And we need to chop that data up. So we need to say for I in range, and we're going to start at position 25. Yeah. 25, because 0 to 24, right? That makes sense. And then 25 down, this all makes sense. And we want to go up to the length of our data, whatever our data is. And to start, we're going to be passing in this test data check. Okay, what do we actually want to find out in this? What do we want to know? We want to know what is the first number that does not have this property. So actually, what we want to do is we want to return the number that doesn't have this property. Oh, okay. So I'm not really testing if the sum is equal to the test number. I'm more testing whether it's not equal to the test number. That's interesting. Okay, so I'm going to keep this return false here just in case anything goes horribly wrong. But in here, I'm going to say else return. And what we need to know is the number. So I'm going to return a test number, I guess. No, I can just return false. Because if it returns false, then I know that whatever the test number was, that's my number. Yeah. Yep. Right, let's go into day 8 and let's just steal a bunch of things. Let's steal these first 2 lines and pop them in day 9 because I need to import my helper function. That will help us read the data later on. Oh dear, I didn't update that in day 8. It's still saying day 7. Let's update that to day 8. That's embarrassing. Day 9. Okay, fantastic. What day is it? I don't know anymore. So we've got our test data. Right, so what are we doing? Sorry, my mind's jumping around all over the place. So for I in range, we're going to start at the number 25. We're going to go up to whatever the length of our data is, and we are going to check our number is sum. So we need our list of numbers. So our list of numbers is going to equal data from a certain position. So we want to go from wherever I is. No, we don't. We want to go from wherever I is minus 25. And actually, what I'm going to do is I'm going to create a variable called preamble size. And we're going to set that equal to 25 because I think this is going to be a useful variable for us. And I'm going to say I minus preamble size. Oh, don't want that in square brackets. And it's going to go from there up to I, right? So that would take me up from 0 to 24. I'm pretty sure that tracks. And let's just print the length of our list of numbers, just so that I know, as a sanity check, that I've got 25 numbers there. Just print that, and we're not running anything, so why would anything happen? What I want to do is I want to say part 1 with test data. Okay, let's run this and check. Let's just clear the console and run this. Your program. Okay. I do want this to run this though. Why is it not? How have I failed already? What's going on? The length of our data is not. Okay. So our test data only has 25 elements. It doesn't have 25 elements in. So I need to start with my preamble size of 5. That's fine. Let's run that. And then I guess here I need to start from preamble size. Okay. There we go. Okay, fantastic. So this is great. This is consistent. This is good. So our length of our list is always 5. Whenever, as we go through this loop, it's always 5. So what are we going to do now? So now what we want to do is we want to pass that in, and we want to pass it in with our test number, which will be the next number in the list. So we're going to say basically this. So let's just take this and pop it in here. But instead of passing it an actual list, we are producing our list dynamically because we're clever programmers. Ish. And so we want to go up to but not including I. So we want to take our data at position I. That's going to be the number we're going to check. And we are going to say, if not result, a lovely, lovely English sentence there. If not result, we are going to print day 9, part 1, and we're going to pop a little colon there, why not? And we're going to print out, what we're going to print out? Our test number, which is data I. And we're just going to then return. So we're just going to stop everything we're doing, and that's the end of that. So let's get rid of this print result, and we're just going to say part 1 test data. Okay, if we run this, we get the number 5. Let's get rid of this print. That really, I was like, oh no, I failed everything. It's all gone wrong. Okay. Day 9, part 1, 40. Okay, now this is not the answer we want at all. We want the answer 127. 40 is actually the first one that does work. So if, let's say, result equals false, let's just check I'm doing this function properly. If sum is equal to test number, okay, I need to go through here. I think I don't think I need. I think this is silly. I think actually my first instinct was right here. Let's run this. Still saying 40. Okay, I've got a classic logic error here. So if my sum is equal to my test number, I'm going to return true, else I'm going to return false. So I will get a value of true or a value of false come back from here. Let's just print up here, just because I'm curious. Let's print my list of numbers and my test number, because I'm hoping there's no overlap here. That would be embarrassing. Okay, 35, 20, 15, 25, 47. Is that what I'm expecting it to have? 35, 20, 15, 25, 47. Great. I'm a dingus. Why am I a dingus? Because this needs to be an integer. Okay. Okay, let's get the basics right. Okay, the basics are right now. Let's run this. And we've got our answer, 127. 127 is the one that we wanted. Okay, finally, I learned how to program good. But half of programming is getting it wrong, okay? The good programmer, accepts that they're going to get it wrong and is happy to adapt to what they do get wrong. That's the truth. So that's part 1. Well, that's not part 1. That's the test data that we've been given the answer to. They tell us that the answer here is 127 in these numbers. But we don't actually want to check these numbers for this. We need to be checking our puzzle input, which is this huge block of text that we've already put in this text file here. It's 1,000 numbers. So let's run it with this instead. So we're going to say our puzzle data is equal to helper.read file, and we are going to tell it to read the file that's in the 2020 folder, and it's called day 9 data. Do you know what? I've got a really good feeling about this, and I really hope it's not misplaced. So let's take these variables away from these functions and pop them down here. Bosh, bosh. Okay, let's close test data up. Let's close our function up. Look at this code. How succinct is this? We print out a line and then we say puzzle data equals this, and then we just say do part one. Lovely stuff. So we're going to open that file and then we're going to pass in our puzzle data here, and hopefully it's going to spit out an answer for us. Let's see. 16. Is that right? That seems way too low. I was expecting like a million. 16. Oh, no. Hang on. I didn't change my preamble size. Rookie error. I need to change that back to 25. I knew. I told you it was too low. I forgot that we in the real data we have to use a length of 25. They dropped it down because they wanted to keep the test data small. Okay, let's run this. There we go. There we go. That's what we're looking for. This is the kind of number we'd expect from Advent of Code. 16. I could have brute forced that in like 17 tries. That would be super easy. But no, this would take me a few more tries. What is this? Some kind of billion, maybe a trillion, depending on whether you're American or British or however those numbers work. So let's pop our answer in here. And let's submit. And here we go. Moment of truth. The best box on the internet. Will we get our star? Let's find out. Yeah, we did. Yes, we did. Another gold star. We now have 16 gold stars. And we are continuing on to part 2. We are 1 gold star closer to saving our vacation. Okay, let's do this. Let's finish this off. So, the final step in breaking the Xmas encryption relies on the invalid number you just found. Okay, so that crazy number we just printed out here, apparently this is important. Let's find out why. Let's get rid of this as well. You must find a contiguous set of at least 2 numbers in your list which sum to the invalid number from step 1. Again, consider the above example. In this list, adding up all of the numbers from 15 through to 40 produces the invalid number from step 1, 127. So if you add up 15, 25, 47, and 40, you would get 127, which is our answer from the test data. Of course, the contiguous set of numbers, contiguous meaning they're all next to each other, or one after the other, set of numbers in your actual list might be much longer. No doubt about that, seeing as our number is like a billion million. 1,000 billion quintillion. To find the encryption weakness, add together the smallest and largest number in this contiguous range. Okay, so not only do we have to find the contiguous range, we then have to take out the smallest and the largest, and we have to add them together, and then we have to give our answer. Okay, let's let's take all of this and let's just copy that and paste it into here. Because boy, are we going to need it. Let's come down here and let's just paste this, and we'll just comment it out. And okay, this will help try and keep me focused in this, because I'm about to go absolutely ham on writing functions here. My brain's already whirring. Let's just make sure we can see all of this. Okay, so again, we need to go through. So we found this. So part 2 actually relies on getting the number from part 1. So in part 1 here, what I want to do is I want to return data I, and then we can use that in part 2. So I'm going to say def part 2, and we are going to say what happens when we run part 2. Well, we want to be given the data so that we can run part 1, and we are going to then say our what is it? Encryption weakness. No, what word did they use for it? Invalid number. Okay, so let's call it our invalid number. Invalid number is equal to part 1, which we've written just above, and we're going to pass it our data. So part 1's going to run, it's going to do all of this inside there, and it's going to return to us our invalid number. And so invalid number will then be whatever that number is. Lovely, lovely stuff. Also, we probably want to take an integer copy of it. So let's say int data I, so that I don't trip over this later down the line. Okay. So now what we need to do is we need to do some checking, right? We need to be going through this list of data and checking which ones add up to it. So I need to be given a list and a position. So I'm going to say sum f sum list. And I'm going to say while, let's say sum is equal to 0. What are we going to pass into sum list? Well, we're going to pass in our list of numbers, and we're going to pass into it our target number. Okay, and target number is going to be our invalid number when we use this list. So while our sum is less than or equal to, while our sum is less than our target number, we want to say position. I guess what we also want is a position as well, right? So we're going to say while sum is less than our target number, we're going to say sum plus equals our list of numbers at our given position. And then what we're going to do is we're going to say our position is now equal to position plus 1. So we're going to add 1 to our position, so that when we come back to the top of the loop, our sum, if it's still less than target number, we're then going to add to our list of numbers from our new position, which will be 1 ahead. I'm going to keep going round. Now, once we break out of this loop, we're then going to check if our sum is equal to target number. Then we are going to return. What are we going to return? I guess I need to take a copy of position here. I need a start position equals position. Okay, so we'll take a copy of that and we'll log it right at the start. And then let's say let's say end position. Let's be really let's be really clear about this. Equals position, and we're going to copy this and we're going to paste this here, here, and here. Okay, so our end position is going to get larger and larger and larger, but our start position isn't going to change. We're going to keep that. And then what we're going to do is if our sum is equal to our target number, we're going to return our list of numbers from our start position up to our end position. Yep, that works. That's all good. Otherwise, we're going to return false. Okay, so now we just need to write a little loop, and this should be fine. This should be absolutely fine. This should be fine. While sum is less than target number, and end position is less than the length of our list of numbers. We don't want it to be any longer, otherwise that would be bad. So we're going to do a quick little loop here. So we're going to say for I in range data, we are going to say sum list, and we're going to give it our data. We're going to give it our target number, which is our invalid number. And we are going to give it our position, which will start at 0. Not data, we need to say the length of data. Come on. So we're going to go from 0 all the way up to however long our data is, and we're going to keep trying to see whether we are able to add some numbers together to make this sum. Okay. I'm not liking how sum is sum an actual function? Sum's an actual function, isn't it? That's why it's this color. Okay, let's change this. Let's call it total. Do that and replace this and replace this and replace this. Okay, that's better. Now it's looks like it will work a bit better. So we're going to say result equals sum list, and then we are going to I know I can say max in Python, and that's fine. Can I say min? Yeah, I can. Fantastic. So what I want to do is I want to say answer is equal to our min of result plus our max of result. Because remember, we need to add together the smallest and the largest number in this range. So I want to take the minimum value and the maximum value. I want to add them together, but I only want to do that if result is not false. I don't know if Python likes that. I don't know if I have to do this or not, but I know this works, so I'm going to stick to that. If result is not equal to false, then what we're going to do is we're going to say our answer is that, and we are going to print. Actually, I'm going to push this inside the loop here. Then we are going to print, and we are going to break. What we're going to print, we're going to print part 2. No, day. Where are we? What part is it? It's day 9, part 2, and we are going to print out our answer. Lovely. And let's make this a string rather than getting a lovely error. Okay, I've got a good feeling about this. Now, to start with, I'm going to use our test data just to make sure everything's working. So I'm going to set my test data there. I'm going to remember to jump in here and set this back to 5. So our answer for this should have been 62. So let's see if we get the answer 62 here. And I'm not running part 2. That's awkward. Let's run part 2 instead of part 1. And we've got a lovely error here. Okay, fantastic. So line 28, it looks like. So let's jump into line 28 and have a look at this error. So total plus equals list of numbers. And of course, what we want to do is we want to have our list of numbers as an integer, because it's a number. I really think if I was more thoughtful, I would have just converted this whole list into numbers to begin with, but hey ho. Okay, we have 1,547, which is not the answer we were looking for, which is slightly awkward. And I think it's probably because these, again, are strings, and we should be adding 15 and 47 together. I'm an absolute dingus right now. Absolute ding. The amount of times this int has thrown me off is ridiculous. If I was a thoughtful person, I would have just been like, yeah, I'll just convert all the strings to integers at the start, and I won't have to worry about numbers adding together weirdly. But hey ho, here we are. Let's run this. 62. Fantastic. We're geniuses. We're absolute madmen. Look, there's 62 there. It works. I'm a clever person. Oh, it's all going so well, and nothing's wrong at all. Okay, I think we've done it. Let's try. Let's see what we get. So puzzle data now instead of test data. Let's run this and let's see what we get. Here we go. The big finish. This could be. Oh my goodness! It's like half an hour. I could have solved day 9 in half an hour. This could be a record. Let's have a look. Okay, I didn't. I forgot again. I need to check. If a cleverer man than me would have changed this to a global variable rather than hiding it in this function, but hey ho, okay, let's do that. Okay, here we go. This is where it's going to work. So we're going to get 127. No, we're not. We're going to get that 1 billion number, and then we're going to get another number that's probably going to be bigger than it. No. Yeah. No. Probably not. Let's have a look. Bosh. Well, bam. Smaller than it. Okay. This could be it. This could be the answer. This could be this could be all my dreams coming true at once. Okay. Let's have a look. The encryption weakness in our Xmas encrypted list of numbers. Is it? Oh, hello. Control V. This, which is 137,394,018. Yeah, you know we did it. We got another gold star. This is so good. We've completed day 9 and we are on the path to victory. I'm so happy. Day 9 has just been my jam, you know? It's been real good. So the only chink in our armor here is this 7 where we've only got 1 star. Now this was the bags, and I just want to break from the bags. I will come back and I will do this, but not today. It's not going to happen. We've really quickly solved day 9. I'm really happy with this. Clearly, programming for like an hour every day is doing me some good, which is great. We've written a couple of functions here to help us do this. The code, although it might look a little bit garbled, is actually fairly straightforward in what it's doing. And I've tried to be really thoughtful in how I'm separating things out and trying to keep things not too complicated. You can see here, each of these functions are not too many lines, maybe like 10 lines of code. But when we combine them together, we can do quite complex things. I'm really happy. I'm waffling now. Thank you for watching. Have a lovely evening. And I hope to see you tomorrow for day 10, where hopefully we will solve that as well. Awesome. Take care.